All right, so let's see what we, well, actually, going to the objectives, last class, we used the discriminant to determine the number and types of solutions, and this helps us pick the best method that we would use on a quadratic. So that's the other objective that we have. Determine the best method for solving a given quadratic equation. So knowing what you have can help you decide which one is better. All right, and again, when in doubt, you could probably just pick one, right? But there are some weaknesses, like factoring cannot be used on all of them, right? So there are certain ones. Graphing also requires a lot of work. It works, okay, but you do have to do a little bit of work, and it's kind of difficult to graph things that are irrational or decimals or anything like that. Square roots are great for ones where there is no b term. And then you have quadratic formula, which is great, works on everything, but it is quite a bit of setup, and you do have to remember the, you have to remember all the formula, and it's a pretty long system, but it works out pretty much all the time. Then there's completing the square, which also has a lot of steps in it too. So what we're going to do is we're going to take one. I think these are all going to be the same one. Yeah, it's all this x squared plus 6x plus 5. So we're going to take this one problem and we are going to solve it in most of the ways. I think it's about all of the ways that we've covered before. So graphing, how do you graph this? So this is actually one we haven't covered in a while, so this might be a little bit of a throwback, but the first thing we want to do is we want to get the axis of symmetry. And the axis of symmetry, we use the negative b over 2a formula. And that is where the turning point of the parabola will be. All right, so negative b, and you might also notice that this kind of looks like the quadratic formula. It's missing the plus and minus square root of b squared minus 4ac, but it does kind of look like, if you were to remove all of that extra stuff, it does look like it. And there's kind of a reason, and a lot of this stuff really does kind of go from one to the other. So if you really pay attention, it could be kind of easy to remember these because, again, a lot of them are the same. It all comes from the same thing, I should say. All right, so negative 6, and I'm going to go ahead and multiply 2 times 1, so it's 2. And I have negative 6 divided by 2, which is negative 3. So I know that this axis is at negative 3, our x-axis here. So let's go ahead and mark out negative 3, like that. Now, whatever our parabola does, if it goes here, there, whatever, it's going to be the same, and it's going to pass through this point here. This is also where our vertex is as well. One of the other key features we need of the graph is going to be the vertex. So that vertex, again, is the turning point of the graph. And you would find that by taking your axis of symmetry and plugging it in for x. So negative 3 squared plus 6 times negative 3 plus 5 equals 0. So there you go. I plugged it into our original equation, but I'm evaluating at negative 3. And in a sense, what I'm doing is I'm asking the function, right? That's our function. I'm asking where is the point that our graph goes through at negative 3. So it could be anywhere along this line. So let's go ahead and evaluate it to see what we have. So negative 3 squared, so that's negative 3 times negative 3, which is positive 9. Now we move to the second term, that'd be negative 6 times negative 3, so minus 18, then plus 5. And in this case, I don't really need the 0 actually. So what I'm going to do is keep going. So 9 minus 18, or what I like to do, instead of just going left to right, I like to take care of my positives and then the negatives. So I'm going to put 9, which is positive, and 5, which is also positive, together. There, now I only have one positive and one negative. And this might make it a little bit easier because now I can easily see that there is a 4 difference. And my negative is a larger number, so that would mean that my number is negative. So this means go back 3 up, or sorry, not up, down 4. Actually, I better double check this to make sure it is at 3. All right, looks fine. So this is our vertex. We're also going to need a couple of other things in order to graph this. It would be helpful to know the zeros, or what we call the roots or the x-intercepts, and that's where it crosses our x-axis here. But in this case here, remember, there's also another trick I've shown you before, and that is if there is no a value, you can just use what we call the rule of odds. The rule of odds is if there is no a value, so there's nothing here, for every one step over, it goes up by an increasing odd number. So in this case here, the first odd number is 1. So as I go over 1, I have to go up 1. And then from that location, if I go over again, I have to go up the next odd number, which is 3, because after 1, it's 3. And then from there, I have to go 5. So over 1, up 5. And if I had kept going, it would be 7, which would be about 12, which would be about right there. Which in this case, I run out of space on my graph, so I don't really need to mark that last spot. And then I just do the same thing so that it mirrors across the axis of symmetry. So 2 spots here at this height, 3 spots here at this height. And that should be our parabola. And I'm going to use my graphing tool, or this line tool here, to try to get through as many of those as I can. Okay. And put little arrows so that we know that this goes on forever. And there we go, we got it. Now, by solving this one for graphing, it works because we were able to use the rule of odds, and I can see where it crosses. So -2, -3, -4, -5. So I know that one of them is -5. So x equals -5 and -1. So I put them in numerical order, just from least to greatest. And now I have both of my solutions. But in this case, I'm kind of lucky because I am able to use the rule of odds and see exactly where it crosses. And this gets really tough if you have to cross at a decimal point or an irrational number, or even if we were looking for the exact imaginary number of where it would go. But if it was an imaginary number, it wouldn't be crossing this at all. So there we go. That's how you would graph it. And there's a couple of other things too. Like for instance, if we were not able to use the rule of odds, then we'd have to use a table. And just to, okay, so we're done with this problem. I'm just showing you how this works. So we would have our x value at -3, -4, and then we'd make a table, pick some numbers going up. So that'd be -3, -2, -1, and then some numbers going down. And it would look something like this. And then we'd plug each of these numbers, all of the numbers that we don't have, back in here, and we'll get a number set out of here. And again, that's what you would do if there were decimals or anything else like that. If it didn't cross at a nice whole number or integer. Anyway, so I think we're done with graphing. And again, graphing doesn't work with all types of problems. I just mentioned some ways that it won't work, or it would be very difficult to make it work. But it does actually kind of always work. I guess I should take that back. Graphing does work most of the time. You just got to do the table thingy. All right, so let's go ahead and move on to the next one, which is factoring. So what do we do with factoring? Now I'm going to stick with my method, and that is the Loif method, which is basically FOIL going backwards. Now to do this one here, first thing we have to do is set it equal to 0. All right, so whatever we have, we got to have this equal to 0. So I'm going to go ahead and make my double bubble. I used to call this double bubble method, but now I call it Loif because now Loif actually makes a lot more sense, because again, you start with the last number, which in this case is a +5. So I need 2 numbers that can multiply to 5, but will add to 6. So adds to 5, multiplies to 5, adds to 6. Man, I should have had some more coffee this morning. And in this case, it's pretty easy, but I also tell people to look at the signs first, because a lot of times the number is not very difficult to get it wrong. I still see it wrong, people picking the wrong numbers, but more often The most common thing I see is people picking the wrong signs. So remember, this is also means it's going to be the same, because if you're multiplying something to get a positive, it can be 2 positives or it could be 2 negatives. But that means they're the same. If it's a negative, if this third term is negative, then that means they are different. And if they are the same, they will be the same as whatever the first one is. So in this case, works out pretty easily. We have a plus plus here. And 2 numbers that multiply to 5. In this case here, we're kind of stuck because there is only one set of numbers that we can multiply to get 5, because 5 is a prime number, meaning that there are no other factors that we can use. And 1 plus 5 is 6. Just getting a little spacey today, that's all. Needed like a soda or something. All right, so you got to set it equal to 0, because we're going to have to use a property called the zero product property. The zero product property basically states that if I have anything times 0, it comes out to 0. Now, we call them zeros. Remember that on the graph, the x-intercepts are called roots, zeros, or solutions. In this case, they're called zeros because we want to know what we can put in for x where it will equal 0. All right, I kind of hope that helps. So that's why we call them zeros. So what could I plug in here for my x to make 0? Now we could try some numbers, like if I plug in, say, -1, right? If I plug in -1 plus 1, that would be 0. And then I'd have -1 plus 5, which would be 4, and I'd get 4 times 0 equals 0, so that's true. But we also have another way of doing this, and that is to separate each of these factors into their own groups. And that's what I'm going to do here. I'm going to factor them into their own groups. From here, I'm going to have to solve them using some basic algebra. And while I'm at it, I'm going to do both of them at the same time. So I'm going to minus, whatever I need to get it equal to 0. So in this case here, there's our first solution, -1. And then we have our second solution, which would be -5. And there we go. So yeah, there we go. And those are the solutions. Now again, this is the same problem. Looking at the other one we had, we should get the same solution. In fact, if we didn't get the same solution, then we know we did something wrong, because this is the same problem from the last slide. So we'll go back over there, and we have -5, -1. Oh, and actually on this one here, not super important, but our vertex would be -3, -4. I mean, in this case, it wasn't part of the direction, so I just left that out. But remember, the vertex is 2 locations. It's 2 coordinate points, the x and the y coordinate. Again, not a big deal. It wasn't part of the directions or anything like that. But just a quick review. And that's what this whole thing is. This whole thing is basically a review of all of the methods that you would use for solving a quadratic equation. All right, so let's go ahead and move on to the next one. Next one is square roots. All right, so with this one here, it's a bit of a problem, because remember in this here, let me see if I still have it down here, that square roots is best used when there is no b term, when there is no middle or x term in our quadratic, when it is in standard form. So in this case, we may not be able to solve this one at all. Now, I mean, I could try, but I don't think it's going to be possible. But what I would have to do, actually, let me back up a bit. We'd have to get the x all on the same side, x squared plus 6x. And then I'm going to leave a space in here. Wait, no, this is completing the square. Now, in order to use the square roots method, we would have to square this, like we'd have to have something like that. And then we'd have to take the root of both sides. But since I factored it, we no longer have an x squared. And that kind of drives them, again, this is not a wrong way, but it's not square roots. So in this case here, the Q button on this thing just doesn't work. So we cannot solve this because there is a b value, and that's kind of what I was pointing out before we started this one here. And again, if I were to keep going with this, I bet we could, because, you know, breaking it into the factor, we have x equals -5 and x plus 6 equals -5, which would have to be -1 or something like that. Well, it wouldn't work on this one here, but that's why we say cannot be used solving square root method. But just remember, okay, let me just, because I know I said a lot of confusing things on this slide. Square roots can only be used when you do not have a b value, which in this one has a b value, so we cannot use square root method. So we're going to go ahead and just leave that for this one here. So let's go ahead and move on to the next one, and this was the one I almost did. Completing the square. So completing the square, this is the one that I am going to have to solve for x. So in this case here, I'm gonna start up here because I know I'm gonna need some extra space to do this. Now, again, I'm gonna leave a space here. Now what I need for this one is a perfect square trinomial. So I need to put something in here to make it work. So what can I put in there to make it into a perfect square trinomial? So what you do is you take your b value, so take it, half it, square it. Let me just write that down right here. Actually, I'm not sure, that might not show up. All right, well, anyway, just take it, half it, square it. So in this case, we get 9. So what I need to do is I need to put 9 in here and 9 over here. There you go. Now I have a perfect square trinomial, so that when I do factor this, right? So we're going to use our regular factoring method, which in this case, we would just use factoring because that's already the fastest, easiest way to do this. And we already know that when we factor it, we get something like this. And then we also have to take care of this side as well. So that's 9 minus 5, that would be 4. And then from here, I would take the square root of both sides. So root here, root there. Oh, and there is one other thing you got to keep in mind with this. Well, actually, there's a lot of things you got to keep in mind. Like, for instance, if you have a first term negative here, then you're going to have to factor that negative out first. If you have any type of a or b value, you'd have to divide that out first as well. Okay, so there's actually a lot of things that you would have to remember for this one. So it's not really one that I really recommend. Because in some cases here, if you factor out a negative, you would have to add the opposite to this side here, just a reminder. And in this case here, we take the square root of 4, so we get 2. Now, we also have to break this into 2 parts. And I also tell students too, that if you see a square on the x or whatever you're solving for, that means there are 2 solutions or 2 possible outcomes that you can have. And that doesn't mean there's always 2. Because you could have 0, you could have 1, or you could have 2. So x plus 3 equals positive 2. So that's the top one here. X plus 3 equals negative 2. So that's the other possibility. So we have to consider both outcomes because, again, roots are tricky, right? They don't really have to follow the rules. And I always use this common example here. What number can I square to get 9? And the first thing I'm usually going to get is, well, 3. If you square 3, you get 9, but don't forget there is also a negative possibility, right? Because -3 times -3 would still be +9. And since I'm doing the exact same thing on both of these, I'm going to go ahead and just work on each one. So 2 minus 3 would be -1. And what is this? -2 and -3? -2, -3, they're both negative. So it's going to stack up to make a bigger negative. And we now have our solutions again, which again shouldn't change. We should still have the same solution because it's the same problem. We're just coming up with a different way of working this problem out. All right, and this is not a very long lesson. Oopsie. But we're almost done with it. Quadratic formula. So again, this one's kind of a simple problem. For me, what I usually do is I look at something and I think, okay, can I factor it? And that's usually the first thing I do because factoring is usually the fastest method and it works with most simple quadratics. Okay, so it works with most. And if you can't factor it, then I usually just go straight to quadratic formula. All right, because even though the other methods are pretty good, they do, again, still require a lot of memorization and steps and stuff, and things like completing the square. If this like first term was negative, then that would make it a lot more difficult because you'd have to account for that on the other side as well. So let's go ahead and do quadratic formula. So in order to do quadratic formula, we would need to know what it is. And I think there are some ways of memorizing it. I think there's like some old YouTube videos. I know when I first started teaching, they had them. They'd be like, opposite of b plus and minus square root of b squared minus 4ac. And they have a little song that goes with it. But again, if you look here, it kind of looks like the axis of symmetry formula, which in a way it kind of is like related to that. And then you have here, which is your discriminant. So basically it's the axis of symmetry with the discriminant. Okay, so that might not help everybody. Might help some people, might not help anybody, but that's what it is. Maybe I could come up with a better way of memorizing it. Anyway, so with this one again, you also have to check to make sure it's in order from descending power of x. So x squared, x1, x0. That last one is an x to the 0 power because there is no x. Now let's go ahead and start plugging stuff in. So we want the opposite of +6. So that means I'm going to put in -6. Because remember, the formula says that we need to put a negative in there. Plus and minus square root of b squared. So that's going to be 6 squared minus 4 times a times c. Now, normally if there's an a value of 1, I just leave it out. Because 1 times anything is just going to stay whatever number that it is all over 2a, which again, I don't really need to put the 1 here either. That just sort of adds extra stuff that's going on. Okay, so from here, I'm going to go ahead and start working on the discriminant. And before we even start finishing the problem, we could probably tell what kind of problem we're looking at. So in this case here, I'd have 36 minus 20 over 2 times 1, which is just going to be 2, -6 plus and minus the square root of 16 over 2. And I can take the square root of 16. So since it's going to work out, sometimes you might get an imaginary number or an irrational number where if it's irrational, like if it was like square root of 15 or something like that, I'd have to take out what I could. If it was a negative number under here, then I know it's going to be an imaginary solution, so I'm going to have to take the imaginary number out. So you're going to get an answer with I, and then with both of those, you'd pretty much stop right there because you can't do anything else without getting weird decimal numbers and stuff. But since this one does have a square number in the radical, we are going to go ahead and work on this as it should be. So they both start out with -6. One is going to have a plus, the other is going to have a minus. Take the square root of 16, that's going to be 4. And all over 2. And then continue solving each of these. So again, make sure you split that sign. So here I have 4 minus 6. So that'd be negative 2 over 2. And over here, so they're both negative. So that's negative 4 and negative 6 will combine to make negative 10. And then split it up. And now we have our solutions, which again, we already know what these solutions are because it's the same problem we've been working with all day. Same problem, nothing really all that different. Put it in numerical order, so least to greatest, which in this case they're both negative. So greatest, even though it's still negative, it would still be considered to be greater than negative 5, right? Because would you rather owe somebody $5 or would you rather owe somebody $1? Right? It's better to owe less money than to owe more money. Yeah, there we go. So again, same solution, but that's what we should expect. Because if it wasn't the same answer, then we would know that we did something wrong. And if we did something wrong, then we'd have to go back and fix it. But again, this is just to show you, a quick review of the different methods. So yesterday, or not yesterday, but the last lesson, we covered all of the different ways you could tell which would be the best method. And in this case here, this is kind of a simple problem, and it does work with nearly all of the methods. It just didn't work with completing the square, but yeah, you can use multiple methods, but there is usually a best method, some of them are faster or easier than others. Some will give you more exact solutions. So it really depends on what's going on. And don't forget that you can look at the discriminant to see what kinds and how many of the solutions you will have. All right, so I think that's pretty much it. From here, it just goes on to what we did on the last class. So again, there's the discriminant. That was what I mentioned before. And this is how you would choose the best method. So we went over all of the methods in this case. So you should be able to kind of look at these and tell what would be the best method. But again, if you at least, okay, if you can't memorize all of the methods, try factoring it. And if it doesn't factor, then use quadratic formula, which again, it's a lot to remember, but it is worth it because it works nearly on almost all the problems. Okay, there's even imaginary or irrationals, doesn't matter. It will work on anything. And I think that's it for this lesson. Kind of a short one today, but that's okay. So just a reminder again, this is the last scheduled Zoom. I will continue to have Zooms until the end of next week. So next week, Thursday, and that is the 27th, is our last day. Make sure you get your final exams in there. Your final exam is under the name of week 18 packet. I don't have an example to show you. I guess I could just skip on over to, the web page. Let me see if I have it up already. Just as an announcement, just so if anyone's needs clarification on what's going on, go ahead and go over to there. So again, well, this is where we are, right? This is the last page of the packet of week 17 that I gave you, so week 17 packet. There is also another packet that should be heading out to you. I think I called it week 18 part 1 because I didn't want to put week 17.5 or anything like that, because then I don't know, I didn't want to confuse anybody, but I guess it's still confusing. Again, I was just missing one day on for attendance reasons. If you turn in an assignment, then the attendance is counted for that day. So that is week 17. And I'm hoping that you'll turn it in on 5/24, which is Monday, because these do take a little bit of time to grade, okay? Once it's turned into the school building, it can take up to a day for us to get it sorted out. And then once it's sorted out, it's usually sorted by some of the front office or the library people. They sort it, and then they have to, once they sort it, they have to give it out to the teachers. which usually the teachers have to make time to go down there and pick it up. So it does take a little bit of time, and then we grade it and then turn it back in. So, you know, try your best to turn them in on Monday. Start, you know, crunching this weekend if you have to. Now, I don't have the week 18 part 1 packet. I do need to upload that here on Schoology. But again, this one here, I'm hoping it's going to be in by 5/24. You know, try not to have it any later than Wednesday. Now, just because I say don't have it later than Wednesday, okay, that doesn't mean if it's Thursday it's 0, no. All right, or if, you know, turn it in on Monday or whatever, okay? I'm just saying turn them in as soon as you can. And I even wrote that on the packet, so make sure you can give me enough time to grade it, because, you know, in this past week, I had like in one day, I had like 20 packets turned in one day, you know, on some days. So it does add a lot of work that comes in a short amount of time, and that's a lot of stuff to grade. And I don't want to be grading, you know, right up on like Thursday evening when grades are due, because some things might not end up being counted. So please, please, please start turning in stuff as soon as you can. And I know sometimes it's tough to turn things in because you're thinking, oh no, I'm going to fail anyway, or whatever. You know, I know we're having weird situations with the grading thing, but I am going to have to recommend people for summer school, and it's going to be, I don't know how that's going to turn out. But anyway, yeah, so this is the final exam, and it counts as your attendance for the final week. So it outlines that in the rubric, I think, right here. So that's your attendance for Tuesday, Wednesday, and Thursday. Check your grade on Parent Portal if you have it, the Power Teacher thing, because that tells you which day goes to which assignment. And I think I have it filled out for the entire rest of the semester, which is not that long. So, you know, if it helps you plan out what you need, and I've already sent out grades, I think on Monday, about what everyone's grade was up until that day. So that way you know what to expect. But again, I'm not 100% sure on that, because, you know, we might change, and we're still discussing some of these things. I don't know if there's any finalized like grading method or anything like that. But I will let you know as soon as I know. Oh, actually, there is one thing I also would like to put in as well. I don't remember if it was this class or which class. I think it was my 3rd hour. But one of them was saying, my teacher told us that we have until January 30 or something like that. We have up until January 30 to do this. Now, that is if you are going to summer school. This is the way I understand it. It's if you are going to summer school, or if you are willing to take a grade of incomplete. If you take a grade of incomplete, then I think you will get that time to work on the grade. But the January or July, June 30. I don't remember what I said earlier, but I meant June 30. Why do they have so many months that start with J? But yeah, June 30, they said that's the last day, but that's, again, only if you're going to take an incomplete. That is only if you are doing summer school. All right, so I know some teachers were saying that, and I think there is a lot of confusion about the grades, because again, I think a lot of students are under the belief they have until June 30. But again, that's the way I understand it, because we had a meeting about it Monday at the end of the day. So I know that was one of the things that we discussed, was that the June 30 deadline is only if you are going to take an incomplete or you are going to do summer school. That's the only thing that as far as I know. Okay, and again, this is all going to change, and I know a lot of teachers are having problems understanding this too. Okay, it's just because we're all being told different things, and it's kind of hard to gather all of this at once when we haven't had a meeting to explain all of this. So I think that was another thing that a lot of students were saying. So I hope that clears up everything till the end. And if you have any questions, don't be afraid to tell me. You know, don't be afraid to send me an email, because I know that there are things out there like this. Anyway, if there's nothing else, I'll go ahead and put an end to this lesson for now. All right. So, well, take care. Bye-bye.
Okay. Bye.